Hi students. In this lecture, I am going to discuss problems based on a rolling on inclined plane. Let us see first one. A hollow sphere is released from the top of an inclined plane of inclination theta. What should be the minimum coefficient of friction between the sphere and the plane to prevent sliding? Find the kinetic energy of the ball as it moves down a length L on the incline if the friction coefficient is half the value calculated in part A. Okay. So in this first part, it is very simple and direct one. Minimum coefficient of friction. So we have learned this in the last lecture. It is beta upon 1 plus beta into tan theta, right? It is a hollow sphere. Coming to second part, we have to calculate kinetic energy as it moves down a length L on the incline if friction coefficient is half the value calculated in part A. That means see what happens here. When mu is not sufficient, it will be rolling with the slipping. Okay. Let us see how to calculate. It is given a hollow sphere. Given hollow sphere angle theta, hollow sphere, minimum coefficient of friction mu s, minimum values beta upon 1 plus beta into tan theta. In case of a hollow sphere, beta value 2 by 3. So 2 by 3 upon 1 plus 2 by 3. That is a 5 by 3 tan theta. That means this value how much? 2 upon 5 tan theta. Okay. So this is a minimum coefficient of friction required to have rolling without slipping. Now coming to second part, mu value is only half of this value. That means now present mu value, it is 1 upon 5 tan theta. So since mu is not sufficient, it is now rolling with the slipping. Okay. So now we have to focus how to get a kinetic energy. It moves down by a distance L. Then we are calculating kinetic energy because of translation and because of rotation separately. So in this case, we cannot write VCM equal to R omega. So here what I can do is starting from rest. So U value 0. Displacement L. I am focusing final speed. Okay. Acceleration is known. That is G into sine theta minus mu cos theta. So I am focusing only translatory motion. Okay. So when a body slides down the incline, acceleration equal to G into sine theta minus mu cos theta. Now substitute in this with the value of mu 1 by 5 tan theta. If you write here 1 by 5 tan theta, then see how much we get. A value G into sine theta minus mu value 1 by 5 tan. Tan is sine by cos. Cos gets cancelled. Remaining 1 by 5 sine. It is 4 by 5. 4 by 5 sine theta. Okay. So we got now A value. So U is 0. V value we want to calculate because kinetic energy equal to half mv square. So I am taking equation here. V square minus U square equal to 2as. 2 A value 4 by 5 g sine theta 2as is equal to n. This is speed of center of mass. Okay. So we got v square value. V square minus u square equal to 2a. Yes. Then we can find half vcm square. Okay. Next, coming to kinetic energy because of rotation. Because of rotation. And you can see here rotation is because of frictional force. Right. So frictional force is now. It is a kinetic which is equal to mu into mu value 4 by 5, wait, mu value 1 by 5, mu value 1 upon 5 tan theta, 1 upon 5 tan theta, mu, mu mg cos theta. I am writing here mu into normal reaction. Okay, mu into normal reaction. Normal reaction is mg cos theta. This is a frictional force. Frictional force is providing now torque. So into R, that is equal to I into alpha. I value, it is a hollow sphere. So 2 by 3 mr squared into alpha. See why we are finding alpha means if we know alpha value, we can write omega equal to alpha t. Okay. Then we can find a half I omega square. Right. Now simplify this. Tan. Tan is sine by cos. Cos gets cancelled. Remaining is now it is mg sine theta by 5. You can see 1 r gets cancelled, m gets cancelled, alpha equal to alpha equal to alpha equal to 3 by 10. See carefully. Alpha equal to 3 by 10 g sine theta and r here. Okay, one r is left here. That is now alpha 1. 3 by 10 g sine theta by r. So once it is known, I can write kinetic energy because of a translation, sorry, because of rotation, half I omega square, where omega equal to alpha t. Alpha is known, but t is not known. Okay. Half I omega square means alpha square t square. So to find t value, see what we can do. So here displacement equal to L. Displacement equal to L. Acceleration is known. That is how much acceleration? 4g sine theta by 5. So from this we can find time taken, right? We can find time taken. So how we can find? I'm taking here u0, u0 displacement is known, acceleration is known. We want to find out t value. So we can write s equal to half a t square. A value 4g sine theta upon 5 half a t square. So I want to calculate from here directly t square value because here we take omega square means alpha square t square. So I want to take directly t square value. From this we get t square value. Now we can substitute that here. Okay. So first let me calculate kinetic energy because of translation. Kinetic energy because of translation is equal to half m bc square, right? I think here 2 can cancel, okay? 2 into 4 by 5 g sine theta into L. 2 gets cancelled. It is now 4 by 5 mgl sine theta. This is the kinetic energy because of translation, right? Now, because of rotation, half I value 2 by 3 mr square omega square. In the place of omega, writing alpha t. Okay, alpha substitute here 3g by 10r 3g by 10r sine theta 3g by 10r sine theta whole square, that is alpha square t square. In the place of t square, see what we can write from here. T square 2 here 2 times, remaining is now in the place of t square 5 L upon 5L upon 2g sine theta 2g sine theta. Let's see calculation part carefully. 2 2 cancels, okay? 2 2 cancels. Next, what else? See carefully. R square gets cancelled. Next, anything else we can cancel here? Check once. 3 square, that is 9. Here 3 is left. 3 square and 3. Remaining is 3. Remaining is 3. Next, see what else left. M is there. M. Wait, it is now 3 square 9. This is 3. 3 is left. This is now 10 square 100. 100. And here what we have? 5 by 2. Then see 100 and this is 2. 200. 200. This is a 5. Means 1 by 40. So by 40. Okay. Right. Let's next see anything else. Here g square, here g. 1 gets cancelled. Sine square and 1 sine gets cancelled. So remaining is now g and L. L is there. mgl sine theta. See anything else I have to write here? 9 by 3, 3 mgl sine theta, okay. 10 square 100, 2 is there, 200, 5, 1 by 40. I think it is okay. Next. Now we have to take sum of these two. Okay. Sum of these two means see what happens now. Total value. Kinetic energy is equal to translation plus rotation. So mgl sine theta, mgl sine theta. Remaining is now, this is now 4 by 5. This is now 4 by 5 and this is now 3 by 4. 4 by 5. That means I can write that as multiply and divide with 8. 32 and this is a 40. 32 by 40 plus 3 by 4. So our calculation is okay. 32 and this is a 40. mgl sine theta. 32 plus 5, 35. 35 by 40 means 7 by 8. 35 by 40, 7 by 8, 5, right? 5 7 times, 5 8 times. 7 by 8 mgl sine theta. That means you have to focus here. It is rolling with the slipping. In such a case, we have to calculate a kinetic energy because of translation separately by using kinematics like this. Next, because of rotation separately by finding first of all torque from that alpha, then taking half of omega square. In this, we don't know what is it t. For that, again using here, we have taken here s equal to half a t square. From there, we got t square value. Okay. Then remain just calculation. So this is a final answer. And this question is taken from H.C. Verma. Let us see now the next problem. Coming to the next problem. Right. See the question given. A hollow sphere of mass 10 gram is released from the top of an inclined plane of inclination 45 degree and a height h equal to 8 meter. The coefficient of friction between the plane and the sphere is 0.25. The work done by force of friction as the sphere rolls down the inclined plane is. So first of all, focus here. First, what we have to focus here, it is a hollow sphere. Hollow sphere, inclination 45. So first we are focusing here, minimum coefficient of friction required. Okay. That is beta upon 1 plus beta tan theta. That is tan 45 1. Beta upon 1 plus beta. Hollow sphere 2 by 3 upon 1 plus 2 by 3. It is 2 by 5. Right. Just now we have solved same kind of question. Hollow sphere. So minimum mu value required 2 by 5 tan theta. Tan 45 1. So 2 by 5, 0.4. Right? But given it is 0.25, which is less than the minimum value. That means it is now rolling with the slipping. It is rolling with the slipping. So in that case, to find work done by force of friction. So what we can do is here, initially height equal to 8 meter. Okay. See carefully. This is almost same as the previous problem. The only extra part what we are doing here, you can see initial height given, height equal to 8 meter. So if you take energy conservation, initial energy mgh, h value 8. Finally, when it reaches ground, it is a half mvc square plus half 5 omega square. So exactly same thing what we have done in the previous problem. Same. Finding VC value by using kinematics. Finding omega value. First finding by using torque alpha value. Then omega alpha t as it is same process. But since it is now rolling with the slipping, because of a slipping, energy is lost due to friction. Remember, when body rolls without slipping, there is no energy loss. Okay. But in this problem, it is slipping. It is rolling with the slipping. So because of that slipping, energy lost due to friction. Therefore, work done by friction is equal to loss in the energy. Okay. That means if you want including sign, because due to friction, work done is negative. So this is now equal to negative of mgh minus this final value half m vc square plus half 5 omega square. Okay. And after making calculation, this value comes out to be 1 joule. Okay, this value. And why I have taken negative sign means because energy is lost because of friction. That means by friction, work done is negative. That's why here negative sign. Okay, because this mgh is greater than this value. Okay, so answer is now minus 1 joule. Right. See next one. Let's see the question given. A small sphere of mass 1 kg is rolling without slipping with a linear speed v equal to root of 200 by 7 meter per second. It leaves the inclined plane at point C. The ratio of rotational and translational kinetic energy of the sphere when it strikes the ground after leaving the point C is. Right. See how to start the problem. Given velocity, it is root of 200 by C, right? Leaving here, height is 1 meter, angle 30, right? Let us see how to start it. First of all, make a diagram, that given diagram. Given 30, height is 1 meter, So it is now rolling with a speed. That speed is given root of 200 by 7 meter per second. Ratio of rotational and translational kinetic energy when it strikes the ground after when it strikes the ground. Now see what we can do. First of all, when this is rolling, it has energy because of translation and because of rotation. Okay, it is given solid sphere. Solid sphere means see total kinetic energy equal. It is equal to half m bc square into 1 plus beta, 1 plus 2 by 5, since it is now solid sphere, right? Now see what we can say. When this is reaching top of the incline, since no energy is lost. So here total energy remains the same. Out of that, coming to kinetic energy, see height is 1. Height is 1, mass is 1 kg. So potential energy equal to mgh, h value 1, that is 10 joule. Okay. So here you can see total kinetic energy. See how much it is? Half m value 1 v square 200 by 7 This is 5 plus 2, 7. 7 by 5. 7 gets cancelled. This is 10. Here, 10 how many times? Remain 20. This is now 20. So total value is 20. Potential energy is 10. So remaining kinetic energy, how much? It is only 10. So on reaching topmost point, its kinetic energy is only 10. Okay. And once it leaves contact, you can see because of rotation, kinetic energy does not change. Because once body comes into air, the only force acting is gravity, which is passing through center of the sphere. And because of this, no torque is produced above center of mass. That means alpha zero. Alpha zero means omega constant. That means rotational kinetic energy does not change. And rotational kinetic energy, you can see how much, what is its value. Rotational kinetic energy will be out of total 20. See the fraction how much. It is 2 by 5 upon 7 by 5. Okay. Total value how much? 7 by 5. This fraction is now 2 by 5. That means it is now 40 by 7. Right? That is now fraction of rotational kinetic energy. And that does not change. Okay. Next, coming to the remaining part. See what we get here. Let me cross check once what we have done is right or wrong. Total value. Total value. Wait. I have taken wrong here. This is not 20. It is only 10, right? At the highest point. Kinetic energy how much? Only 10. This is a 10. 10 means how much? It is 10 by 7, right? It is a 10 by 7. So rotational kinetic energy 10 by 7 Joule. And see what about translational kinetic energy? Translational kinetic energy will be, it is 10 into, it is 1 by 7 by 5. That is 50 by 7. Okay. Now, when this is reaching ground, it gains gravitational potential energy that is a 10 joule. Okay. And that is added to translational kinetic energy. Okay. Because no change in the rotational kinetic energy, adding only to translation. So translational kinetic energy equal to means on reaching ground. Okay. 50 by 7 plus 10 because height is 1. We get how much? mgh 10. 10 is adding to translation kinetic energy 50 by 7 plus 10. So 70 plus 50, 120. 120 upon 7. So now we have to find ratio, right? So ratio of translational kinetic energy to rotational kinetic energy, that is 120 by 7, and it is now because of rotation. See how much we got? Sorry, 2 is left here, right? 2 is a 2 and 10, 20. This is 20. 20 by 7. This is now 20 by 7. Right? 7 gets cancelled. It is now 6. So he's asking now, see ratio for what? Ratio of rotational to translational. So rotational to translation means what happens? It becomes now 1 by 6. So rotational to translation, it is 1 by 6. So here key point is that once it comes into air, rotational kinetic energy does not change. Why does not change means because gravity passing through center of mass. So no torque is produced about center of mass. Means alpha zero. Alpha zero means omega constant. That's why no change in the rotational kinetic energy. Half I omega square. That is a key point. Okay.